we have a board. Now this board is called a circular geoboard, and we can use a circular geoboard to make various types of shapes. We can even use it to make lines. We can even use it to make angles. But today we'll be using this circular geoboard to explore polygons. So we're going to explore 3 different types of polygons. We're going to look at the triangle, we're going to look at the quadrilateral, and we're going to look at the pentagon. Good afternoon, boys and girls. Look what I have here. It's a geoboard, but it's round instead of square. You guess how many tacks are outside of the circle? 5? 10? No, it's more than that. Let's count out. Use 33 tags on the outer part of the circle. And what about inside? How many tags did we use inside of the circle? Great, 1 tag. So now we're going to use a rubber band to make our first shape. So we're going to place our rubber band in the center here, and then we're going to place it on one of the outer tags, and then we'll place it on another one of the outer tags. And you see here we have our first shape, and this is a triangle. Now let's count how many sides the triangle has. How many? 1, 2, 3. Great. So the triangle has 3 sides and 3 vertices. Now we're going to make the second side. We're going to make a trapezoid, and keep in mind that quadrilaterals have 4 sides, right? So the first thing we do, we take our rubber band and we put it on the 2 outer corners or sides, and then we take the second one and we do the same thing. Then the third one, we're going to put it right on this yellow rubber band where the green rubber band is, right? And then we're going to connect it to this white one. Great. Remember, your shapes doesn't have to be perfect, right? As long as you are trying. Very good. Great. So you see here we have our trapezoid. Now we're going to make our third polygon, and this polygon has 5 sides. And can anybody tell me, what do we call a polygon that has 5 sides? Great. We call it a pentagon. What do we call it? A pentagon. Very good. We already made the pentagon, so we're just going to take our rubber bands and trace it over, right? So first you put one here to here, then you put the next one, and keep in mind you're putting it on the outer corner. Very good. Then you put this one here. Then you put another one here. Then we put one more here, and we have our pen. In closing, how many shapes did we make today using our circular geoboard? 3. Great. And can you remember our topic? Polygons. Very good. One more question. Can you remember the names of those 3 shapes? First we had the triangle, then we had the trapezoid, then we had the pentagon. Wonderful. Give yourselves a little tap on the shoulder. So keep in mind, a circular geoboard is a board we can use to make various shapes and other things. We could even use it to make a line. So let's try to make a line before we go. So we're going to put it in the middle here and then here. And you see here we have a straight line. Thank you.
Today, I'm going to demonstrate to you how to use a geoboard to teach lines of symmetry. Using the geoboard to have a rectangular shape, we're going to get the rectangular first on the geoboard with the rubber band, and then we're going to put the lines of symmetry of a rectangle. First, let's do the horizontal one. Yeah, let's do the vertical one now. The lines of symmetry of a rectangle are 2. The horizontal one, both of the sides are equal, and the vertical one, both of the sides are equal, as you can see there on the geoboard. Now let's make a shape of a square. So that's a square. Now on a square we can get 4 lines of symmetry. That is 1. See, the sides are equal. That is 2. You can have another one. Another line of symmetry, that is 3. And here we have another one. And here we have another one. So we have 1 vertical, 2 horizontal, and 3 diagonal. So we have 1, 2, 3, and 4. So on a square, the square have 4 lines of symmetry. using the geoboard with rubber bands. That is how we can get lines of symmetry.
My name is Miss Tia Livian, and I will be looking at a set of Chinese tangram. We will be looking at a lesson for a grade 3 class. So we will be looking at the topic properties of 2D shapes. Now our learning objectives is by the end of this lesson, pupils will be able to identify basic 2D shapes, for example, triangles, squares, and parallelogram. Describe properties such as number of sides and corners, or vertices as we may know it as, and types of angles. Compare and classify shapes based on their properties. Good. So today for maths, we'll be looking at properties of plane shapes while using a Chinese tangram. Now, in order for us to get the properties, we'll be taking out the shapes from the puzzle and finding the properties. So the first shape we have is our triangle. Let's take out the triangle from this puzzle and find the properties of it. Good, this is a triangle. How many sides does the triangle have? 1, 2, 3. So the triangle has 3 sides. Let's look at the corners of a triangle. A triangle has 1, 2, 3 corners. The pointed sides are the corners. Where 2 ends meet will be the corner. The next shape that we have is a square. Now let's look at the square. Let's count how many sides the square has. 1, 2, 3, 4 sides. And now let's count the corners. 1, 2, 3, 4 corners. And the last one we're going to do is the parallelogram. Hey, why you stop moving? Good, this is the parallelogram, right? Let's count how many sides the parallelogram has. 1, 2, 3, 4. So a parallelogram also has 4 sides, and if it has 4 sides, then it will give us 4 corners as well. Let's go 1, 2, 3, 4. So for today's lesson, we use our Chinese tangram to find the properties of the shapes that made the tangram, right? We had the triangle, this one, the square, and the parallelogram.
Class now, let's look at what this teacher have in my hand here. What's the topic for today?
Fraction.
Okay, lovely. You can tell me what is a fraction?
A fraction is an equal part of a whole.
Good. So can you give me an example of how to do a fraction?
This like when a couple pizza in 8 slices, I will take one in my favorite 70.
Good. So I'm share it equally. Okay? Good. Now here I have on the fraction really. I have how many parts? Let's count.
1, 2, 3, 4, 5, 6, 7, 8.
Good. So how many parts of my fraction do I remember?
8.
Good. So now I'm going to form a fraction and you're going to tell me what part of the fraction it is. Now what part of the fraction is this?
1 more 8.
Good. So using the part that you have, when you them straight on into please.
1 8 is written like this. 1
Okay.
over 8.
Okay, thank you very much. Now, when you take the fraction, and now you're going to show me 3/8 of that fraction.
Okay? Good. Now let's try one more. Let's try one more. Let's go to 5-8. Show me 5-8 and the back to our child. Good. And then name the fraction to the units. Good. Thank you very much. Well done. Okay, now give me a 5 for that. Now, for your fraction, now you're going to tell me how many times is your fraction divided in? How many times?
4.
Let's count.
1, 2, 3, 4.
Okay, good. So your fraction is divided into 4 parts. So let's see how it's going to shade. Let's see how it's shaded. This part, you know, what part of the fraction is shaded?
1/4.
Yes, thank you very much. Yes, 1/4. Only for the city of quarter. Right? Good. So, on the same fraction chart now, show me a half of that fraction. Good, I will name this out for them. Good, well done. Now let's try one more. Let's try one more. Show me a little. A more of that fraction. Good.
Hi everyone. So my task is to make a set of volumetric instruments, measuring instrument that is. So I made 4, and the 4 that I made were a measuring cylinder, a syringe, a burette, and a measuring cup. So all these were made with cardboards and foam. So the use of the measuring cylinder, so we can use the measuring cylinder to measure the volume of liquid accurately. So we can teach grade 5 pupils on how to measure liquids. So say for example, we can fill the cylinder with water at different levels and let the pupil read it, tell us the measurement that they read, and that can bring out the topic of reading liters and milliliters. So that is how we can use the measuring cylinder. Next we have the syringe. So we can demonstrate to pupils how liquid can be measured and transferred in small amounts. So out of a big bottle, we can use the syringe to pull up small amounts and measure. So we can also let pupils use water and squirt it into measuring cups. So that's how we can use the syringe, the measuring cup. We can show practical ways of measuring liquids in our everyday life. So we can have different bottles. We can have bottles of water, we can have chubby bottles, and we can take the chubby bottle and throw it into the measuring cup and see how many average can fill up one measuring cup, but obviously it would have different sizes of measuring cups. So that's how you can demonstrate it to the grade 5 pupils, right? Not only liquid, you can also take to measure ingredients, say for example flour, while cooking and stuff. So that's what a measuring cup is used for. Lastly, we have the burette. So this can be used to introduce a precise amount, how we can control the amount of liquid. So that's what we use this for. So we can show how burette releases water drop by drop, and the children can measure how much exactly was used. So that's how a burette is used. Thank you.
Good afternoon, class. Today we'll be looking at properties of shape. And to complete this exercise today, we'll be using our shapes from the attribute logic set. Now the first shape we'll be using is the square, and we'll be putting in the information as we go along. So let's begin. Now we notice that the square has 0 curved side, so we'll put in 0 in that space. How many equal sides do we have? We have 1, 2, 3, 4. So we have 4 equal sides. Now the next column is lines of symmetry. How many lines of symmetry does a square have? 4. That's correct. Let's see. 1, 2, 3, 4. So we have 4 lines of symmetry. And how many vertex do we have? That's correct. 4 vertex. Now, what is a vertex again, class? Yes, that is correct, Sarah. A point where 2 or more lines or edges or sides meet. Good. Now we look at the triangle. Now with the triangle, we know that there are 3 types of triangle, which would be the isosceles, the scalene, and the equilateral triangle. So what kind of triangle will we be looking at here? That's correct. It would be the equilateral triangle. So we know that there are 0 curved sides. So how many equal sides does the triangle have? Let's see. 1, 2, 3. So we have 3 equal sides. How many lines of symmetry? Let's go. 1, 2, 3. So we have 3 lines of symmetry and 3 vertices. Good. So the next shape we'll be looking at would be the hexagon. And here, can you see any curved side in the hexagon? No. So that would be 0. How many equal sides does the hexagon have? Let's go. 1, 2, 3, 4, 5, 6. So we have 6 equal sides. Then how many lines of symmetry we will have? That's correct. That would be 6 lines of symmetry. Let's draw it in. 1, 2, 3, 4, 5, 6. Now you need to take your time and use a ruler when you are drawing your lines of symmetry. So we have 6 lines of symmetry and 6 vertices. Now the last shape we'll be looking at to complete our exercise for today would be the circle. Yes, the circle. Now with the circle,
can see the curves. So how many curved sides do we have? We have 1. We don't have any equal sides, so that will be 0. So then for the lines of symmetry, because it's a circle, we will have an infinite number. So we will put infinite, meaning that you can go up, draw how many lines of symmetry you need. And how many vertices do we have? We do not have any vertices. That is correct, Mark. So that would be 0. Okay, so copy.
Hi everyone, my name is Solandra Dublin and today I will be presenting to you the throttle wheel. Hi everyone, so today we'll be looking at the throttle wheel. Now the purpose of the throttle wheel is to measure distances, especially long or irregular ones that are difficult to measure with a regular ruler or tape measure. It works by rolling the wheel along the ground. Each full rotation typically equals 1 meter, and clicking sound is made with every turn to help count the distance. Throttle wheels are commonly used in school for math or physical education activities, as well as in construction and land surveying. So a throttle wheel can be a fun and a hands-on tool to teach children in grades 1 and 2 about measurement and distance. Here's how it can be used effectively. So for distance and measurement, we can see that 1 complete turn equals to 1 meter. So there, the children will be able to roll along the ground for a 1 complete turn, and it will be equals to 1 meter. So the children from grade 1 and 2 can estimate distance in their classroom or in their reading room in a particular space. So then they can use the actual throttle wheel to have the correct measurement. With 1 complete turn, it will equals to 1 meter.
Good morning, boys and girls. My name is Miss Makiba James. So today for our maths class, we're going to look at a special mathematical instrument. So boys and girls, do you know what is the name of this mathematical instrument? Very good. This is called a mathematical balance. So boys and girls, a mathematical balance compare and measure different objects. What is balance? So balance is when both sides stay straight. So now boys and girls, I'm going to do a little demonstration to show you balance. So I have one bowl here and another bowl here. So I want to show you how it is balanced. So I'm going to take 2 blocks. 1, 2. Right? I'm going to take another 2 sets of blocks. 1, 2. So I'm going to place these blocks into both bowls. Good. So boys and girls, did you see that one side went down and one side went up? No, it stays the same. It stays straight because it is balanced. So boys and girls, now I'm going to add 2 more blocks into this bowl here. Wow, what did you see? This side went down. So boys and girls, which side is heavier? Good job. This side is heavier because it went down, and this side has, let's count the blocks, 1, 2, 3, 4. This side has 4 blocks, and this side has only 2 blocks. So this side is heavier. So boys and girls, if we want to make this balance, what should we do? If I have 4 blocks in here and 2 blocks in here, how many blocks do I have to put in this bowl to make it balance? Yes, I have to put 2 blocks. Let's count. 1, 2. Wow, and it is balanced. Very good, boys and girls. Give yourself a clap.
Alright, my task was to construct an innovative teaching aid for the primary school. My focus grade is on grade 1. Our topic is addition. An addition can be defined as an arithmetic operation that involves or combining two or more numbers to get a value or the sum, which is the sign used is the plus. Our equation on the board here, on the teaching aid, is 4 plus 5. I have my counters. I'm going to throw it in the hole, and it's going to fall in the box here. So I throw in 4 counters here. And on this one, I have to throw in 5. So now I have to get the value or the sum. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I add 5 and 4, I got 9. So 5 and 4 is equal to the number 9. To the number 9. And this here has brought me to the end of my demonstration. Thank you.